Have you ever wondered why the ocean tastes salty, while lakes and rivers often taste fresh? Today, we're diving into the fascinating science behind the ocean's saltiness. This journey will take us from the land to the sea, exploring natural processes that have been at work for millions of years. By the end, you'll understand not just the what, but the why behind this salty phenomenon. Let's start by looking at what makes up ocean water and how it differs from the water we drink every day. Ocean water is a complex mixture, but its most noticeable feature is its saltiness. Unlike the water from your tap, seawater contains a variety of dissolved minerals and salts. The most common of these is sodium chloride, which is the same as table salt. But there are also other minerals like magnesium, calcium, and potassium. These dissolved substances give the ocean its characteristic taste and play a crucial role in marine life and global processes. You might be surprised to learn that even freshwater sources like rivers and lakes contain small amounts of dissolved salts and minerals. However, the concentration is much lower than in the ocean. This is because as water flows over rocks and soil, it picks up tiny amounts of minerals, including salts. Over time, these minerals are carried by rivers towards the sea, setting the stage for the ocean's saltiness. The process that starts it all is called weathering. Rainwater, which is slightly acidic, falls on rocks and gradually breaks them down. This releases minerals, including various salts, into the water. These minerals are then carried away by streams and rivers. Over millions of years, this slow but steady process has contributed to the accumulation of salts in the ocean. Rivers act as nature's conveyor belts, transporting dissolved minerals from land to sea. As rivers flow, they gather more and more minerals along their journey. When they finally reach the ocean, they deposit these minerals, including salts, into the vast body of seawater. This ongoing delivery is a key reason why the ocean is salty. Another important factor is evaporation. When the sun heats the ocean, water evaporates into the atmosphere, leaving the salts behind. This process concentrates the salts in the remaining seawater. Unlike rivers and lakes, which can overflow and flush out minerals, the ocean is a closed system, so salts accumulate over time. You might wonder why lakes don't become as salty as the ocean. The answer lies in their ability to drain. Most lakes have outlets, rivers, or streams that carry water and dissolved minerals away. This constant flushing prevents salts from building up. In contrast, the ocean has no such outlet, so salts remain and accumulate. Some lakes, like the Dead Sea or Great Salt Lake, are actually saltier than the ocean. That's because they have no outlets, so water only leaves through evaporation, just like the ocean. Over time, salts become highly concentrated, making these lakes even saltier than seawater. Deep beneath the ocean's surface, hydrothermal vents play a role in the ocean's chemistry. These vents release minerals from the Earth's crust directly into the seawater. The hot, mineral-rich water mixes with the ocean, adding to its salt content and influencing its overall composition. Volcanic eruptions, both on land and under the sea, contribute to ocean salinity. When volcanoes erupt, they release gases and minerals, some of which dissolve into rainwater or directly into the ocean. Over time, these volcanic contributions add to the ocean's saltiness. The ocean's saltiness is a balance between inputs and outputs. While rivers, hydrothermal vents, and volcanoes add salts, some processes remove them. For example, marine organisms use minerals to build shells, and some salts settle to the ocean floor. However, the rate of input generally exceeds the rate of removal, so the ocean remains salty. On average, seawater contains about 35 grams of dissolved salts per liter, or 3.5%. This may not sound like much, but it's enough to give the ocean its distinct taste and to support a wide variety of marine life. The exact amount can vary depending on location, temperature, and other factors. Ocean salinity isn't the same everywhere. It can be higher in warm, dry regions where evaporation is intense, and lower near the mouths of large rivers, or in polar regions where melting ice dilutes the seawater. These variations affect ocean currents, climate, and marine ecosystems. The water cycle is a key player in maintaining ocean salinity. Water evaporates from the ocean, forms clouds, and falls as rain. This rainwater eventually makes its way back to the ocean, carrying more dissolved minerals with it. This endless cycle ensures a continuous supply of salts to the sea. The ocean hasn't always been as salty as it is today. In Earth's early history, the oceans were much less salty. Over billions of years, the processes of weathering, river transport, and evaporation have gradually increased the salt content. This long history is recorded in ocean sediments and ancient rocks. Many of the world's salt mines are actually remnants of ancient seas that dried up millions of years ago. As these bodies of water evaporated, they left behind thick layers of salt, which we now extract and use. This is another example of how the Earth's processes recycle minerals over time. Marine organisms have adapted to live in salty water. Some, like fish, and shellfish, have special ways to balance the salt in their bodies. Others, like corals and mollusks, use minerals from seawater to build their shells and skeletons. The ocean's saltiness is essential for the survival of these creatures. Salinity affects the density of seawater, which in turn influences ocean currents. Denser, saltier water tends to sink, while less salty water rises. This movement helps drive the global conveyor belt of ocean currents, which distributes heat and nutrients around the planet. The saltiness of the ocean also plays a role in Earth's climate. By influencing ocean currents, salinity helps regulate temperatures and weather patterns. Changes in ocean salinity can have far-reaching effects on climate systems, making it a key factor in understanding global change. Humans have long harvested salt from the ocean. In many places, seawater is collected in shallow ponds and allowed to evaporate, leaving behind salt crystals. This ancient practice continues today, providing an essential mineral for food and industry. Salt has played a major role in human history. It was once so valuable that it was used as currency and sparked wars and trade routes. The ocean's endless supply of salt has made it a crucial resource for civilizations throughout time. The saltiness of the ocean is immediately noticeable if you've ever taken a swim and accidentally tasted the water. This distinct flavor is due to the high concentration of sodium chloride and other minerals. It's a taste that sets the ocean apart from other bodies of water. Salt doesn't just affect taste, it also makes water denser. That's why it's easier to float in the ocean than in a freshwater lake. The increased density provides more upward force, helping swimmers and objects stay afloat more easily. Salt also lowers the freezing point of water. That's why seawater can remain liquid at temperatures below the freezing point of pure water. This property is important for marine life and for the formation of sea ice in polar regions. The ocean isn't uniform from top to bottom. Differences in salinity and temperature create layers within the ocean. These layers can affect how nutrients and heat move, influencing everything from plankton growth to global climate patterns. Because the ocean is so salty, it's not suitable for drinking. Desalination is the process of removing salt from seawater to make it drinkable. This technology is increasingly important in regions facing freshwater shortages. Salt from the ocean can affect agriculture, especially in coastal areas. When seawater seeps into the soil, it can make the land less fertile. Farmers must manage salt levels carefully to protect crops and maintain healthy soil. Salt can also impact infrastructure. In coastal cities, salty air and water can corrode metal structures, roads, and buildings. Engineers use special materials and coatings to protect against salt damage and keep infrastructure safe. While salt is essential for life, too much can be harmful. The salt in ocean water is far too concentrated for humans to drink safely. However, salt is vital for nerve function, hydration, and many bodily processes when consumed in moderation. Salt has inspired art, literature, and cultural traditions around the world. From ancient salt carvings to modern culinary arts, this mineral has left its mark on human creativity and expression. Salt is used in many technological processes. From making chemicals to treating water, its unique properties make it valuable in industries ranging from food production to electronics. The salt industry is a major part of the global economy. Salt is mined, harvested, and traded worldwide, supporting jobs and industries in many countries. Its economic importance stretches from ancient times to today. Salt has even influenced navigation and exploration. Early sailors relied on their knowledge of ocean salinity and currents to chart courses across the seas. Understanding the ocean's saltiness helped shape the age of exploration. Many cultures have myths and legends about the origin of the ocean's saltiness. From ancient gods to magical creatures, these stories reflect humanity's fascination with the sea and its mysteries. Human activities can change the salt balance in oceans and lakes. Pollution, water diversion, and climate change can all impact salinity, with consequences for marine life and ecosystems. Protecting the ocean's delicate balance is more important than ever. Studying ocean salinity has led to important scientific discoveries. From understanding ocean currents to tracking climate change, measuring salt levels helps scientists unlock the secrets of our planet. Believe it or not, scientists look for signs of salt on other planets and moons. Finding salty water elsewhere in the solar system could be a clue to the possibility of life beyond Earth. As our world changes, the role of salt in the ocean will remain important. Scientists, engineers, and policymakers are working together to monitor and manage ocean salinity for the health of our planet and future generations. To sum up, the ocean is salty because of a combination of natural processes: weathering of rocks, river transport, evaporation, and contributions from hydrothermal vents and volcanoes. Over millions of years, These processes have added and concentrated salts in the sea, creating the salty environment we know today. Ocean salinity isn't just a curious fact, it's essential for life on Earth. It affects climate, marine ecosystems, and even human society. Understanding and protecting the balance of salts in the ocean is vital for our future. Salinity is a measure of the amount of dissolved salts in water. It's usually expressed in parts per thousand ppt or as a percentage. In the ocean, average salinity is about 35 ppt. This concept is central to understanding ocean chemistry and its effects on the environment. The water cycle describes how water moves between the ocean, atmosphere, and land. It involves evaporation, condensation, precipitation, and runoff. This cycle is crucial for transporting minerals and maintaining the ocean's salt balance. Weathering is the process by which rocks are broken down by water, wind, and chemical reactions. This releases minerals, including salts, into rivers and streams, which eventually carry them to the ocean. Hydrothermal vents are openings in the ocean floor where hot, mineral-rich water escapes from the Earth's crust. These vents add minerals, including salts, directly to the ocean, influencing its chemistry and supporting unique ecosystems. The ocean's saltiness is the result of countless natural processes working together over millions of years. From weathering rocks to the endless cycle of evaporation and rainfall, every drop of seawater tells a story of Earth's dynamic systems. Understanding why the ocean is salty helps us appreciate the complexity and beauty of our planet.